Brady Clifford for those listening in. I'm giving a presentation on HTTP2, the infamous protocol that we all have learned to love for the past, 15 years? When was the internet invented? 1999? Isn't that when it became official?
I remember.
I think so.
It's older than some people.
It is. So what I'm going to do, kind of quick little synopsis, I'm going to first talk about the history, and then I'm going to move into the enhancements that have been made and how we can utilize them. Now, for some reason, Prezi is zooming in big time. I think I might actually... It's
weird.
cropping my
Humor.
My humor. I told Jeff that I was going to try to have some comical relief in here, but the chips are here. Well, Jeff brought the chips for to compensate.
11 months. First developer presentation. Gotta have some treats.
Right. So what intrigued me on this is before I came here, I gave a presentation to my last company that I worked for on what they were doing wrong. They hadn't even heard about any of the tools that we use here when it comes to optimizing our web performance. They actually paid a service called, well, you probably heard of it, Akamai, as their CDN. They also use another product called Aptimize. They spent about $250,000 a year on this product, and all it is Webpack. They had no idea. Anyway, so this kind of came from this, and then I had a really good podcast that I listened to back in December. I really like .NET Rocks. They have some pretty good podcasts, and they had a guy that talked about the upcoming HTTP2, and so I've had this back in my mind and just haven't been able to present until now. It's been moved around on Teams so much that I guess it's not an excuse, but I keep getting bumped out because I moved to another team and somebody's already scheduled for that month, so I just have to go to the last. Anyway, so fries with that. So a brief summary, for those who just want to listen in for the first couple minutes, HTTP 1.1 has a limitation where it can only open up 6 concurrent TCP connections and provide something back. So there's a great example of, hey, you want a hamburger, Coke, and fries. Well, let me give it to you in three segments, right? But with HTTP2, we can give it all to you at once. So that's what we're going to be talking about today. All right. This is my first time with Prezi, so there we go. Okay, great. There we go. Okay, history. 1991, HTTP 0.9 came out. So maybe it was 1991 the internet actually started. I don't think it really became mainstream until 1990. Yeah, around there. You got a question, Scott?
I thought you were saying nobody was on the internet back then.
Oh, you raised your hand? I was still, let's see, 1991, I was in elementary school, I think.
I was born.
You were born. So this protocol, really, it's been a really good protocol. It has lasted the test of time, to be honest. We have had to do workarounds around it to compensate for its pitfalls, but overall, it has lasted the test of time. It's lasted for 15 years. Its biggest limitation, as I said, 6 concurrent connections per host. Now, if you look there in 2009, you got this thing called SPEEDY. Is anybody familiar with this acronym?
I am. I don't remember what it stands for, but I know.
I don't either. But this was a child of Google, actually. Google, they had a little little department that decided they wanted to optimize the way that their traffic was handled, and they decided to create this little tool. Its objective never was to replace HTTP. It was only to show what HTTP could evolve to, right? They wanted to kind of test the waters with some ideas. So with SPEEDY, they implemented a few features that allowed you to have one TCP connection with multiple streams, multiplexing, HTTP or header compression, and also what was the last one? I might have it here. There was one more. I'll probably come to that in a second. So going back real quick. So then in 2012, they came out with Speedy 2.0 that added. God, I can't remember what they added. Let me look at my notes real quick. They added multiplexing, one TCP connection, and dependency trees. The ability to say, hey, if I have a jQuery file, this is dependent on this CSS file, this image, blah, 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 be able to have a dependency tree. Now, in 2012, that is when the standards, the people that keep HTTP up and going, the ones that evolve it, came to Google and said, look, we want to take what you learned and we want to add that to the new protocol. One of the things that Google did around 2010, 2012 was they also had to determine what is the most important thing out there. Is it bandwidth or latency? And they did a lot of tests around this. And the test came back that it is latency. Latency is the issue, not bandwidth. It's not how much can we grab down at once. It's how many times do we have to go and do handshakes back and forth. That was the biggest bottleneck that they did through their testing. So Speedy evolved to improve that latency. All right. Okay. So one of the ways that people approach this problem of the 6 concurrent TCP connection limit was domain sharding. And this is something that was considered back at my last company too, but they never went with it. Domain sharding, so that 6 concurrent connection requirement or constraint is dependent upon each domain. So if you actually take your content and you throw it out on a CDN and you throw different subdomains at it, like let's say www1, www2, 3, 4, 5, you can actually reference those in your page, and you can expand that 6 concurrent TCP connection limit because it's 6 concurrent connections per host. So that's one way that people got around it, other than using sharding. More of a physical way of doing it. So again, Google Speedy, they did that test in bandwidth versus latency. To get around the problem, people concatenated and minified. And we currently do that here. We minify our JavaScript or CSS, and we bundle it all into one little package, right? Why do we bundle it in one little package? So that we only do one handshake, one TCP connection to grab that. Hey, just grab, give me everything, here you go. There are some problems with that though, and we'll talk about that in a little bit. Spriting. Do I need to go into detail on what spriting is? Or does everybody know what spriting is? It's okay if you don't. Do you know what spriting is? Okay. I'll just explain right now.
You're talking about sprites?
Yeah, sprites. Yeah. It's where, like let's say you have a website that has all these icons, like copy paste, a person logo, whatever. Instead of going and downloading each one of those individually, which again opens up more TCP connections, which means more latency, which means if you have 6 TCP connections open, you're blocked. You can't download anything else until one of those is done, right? You would take all those images and put them on one image, and then then you would download that entire sprite, is what they call it, and then in your code you'd say, only show this little section of this sprite. Only show this little section for the hand, for the copy, for the paste. Yeah, it's like a bundle of images.
Before OneExchange switched to using font icons, that's what we were doing.
Yep.
Yeah, font icons solves that problem. Sharding, like I talked about, and then another thing people do is inline assets so that the site isn't blocked on waiting on getting a CSS download or an image. Like you can actually put images within a CSS file. So that's how we got around it, right? I'm going to talk about how these things are bad now and how we shouldn't be doing these here in a bit. All right, enhancements. So one of the biggest things that HTTP2 has brought to the table is the ability to have streams. So here I say 1 connection per login, or I'm sorry, per origin. that's still a constraint. However, as you can see, I only need to open up one TCP connection per host. And then from there, I can open up streams. So where I had to open up, like let's say I wanted to download these 4 files here, page CSS, form CSS, jQuery forms. In the old way, I would have to open up 4 TCP connections to grab those, which means 4 handshakes, latency involved. Okay. Now I only have to open up 1 TCP connection, 1 handshake, which takes the longest in most cases. That is where the latency comes from. And then I can spawn off multiplex streams to download these options. So that is the biggest enhancement that we'll get from this. This is a better example of how the multiplexing works. Well, yeah, but this is pretty much what I just said. 1.1, 3 TCP connections, and then in 2, 1 connection that can download multiple. Okay. Any questions so far?
So really quick,
I'm actually going to ask questions as we go.
Can you go back one slide? So you have these bidirectional arrows, and HTTP1 is just unidirectional. So it's each request. Is HTTP2 bidirectional, or is it?
It is bidirectional.
Yeah.
Okay.
It is bidirectional. Yes. So yes, you can push.
Okay.
You can push. The server can say, you know what? I already know that you're going to need jQuery.js, example.cs, and image. You know what? I'm just going to give it to you all at once. I'm not going to send you the HTML page and have you parse it and then decide what you need. I'm just going to send it to you because I know you need this. So yeah, server push is something. It does require a server that can do it, and the ones that we currently run can't. IIS-10 supports it.
HTTP2, right?
Yeah, IIS-10 is what we need for that, or Node has plugins for that. Apache's already up to speed, and there's a few others that are there too. But we're stuck on IIS right now. Any other questions so far?
A quick question. You talk about 6 connections per host. That's a limitation on the client, right? Or is that a limitation on the server?
Both. The client has done some workarounds to kind of stretch that as much as they can, where they open up, they like imitate as if they're another browser in a way, and then they try to get more. But the limitation is about 6. It's really a server that doesn't really allow that.
Okay.
Okay, so the next feature is header compression. In the past, when you have a header, usually headers don't change when you're on the site, other than the token. Actually, the token even stays the same, the JWT token. But now they compress the header with HPAC. They were doing it with gzip with Speedy, but it was hacked.
gzip was?
With the Speedy implementation, so they went with HPAC. So that's another great benefit that will increase speed and latency, or decrease latency.
Is that how different is that from gzip? Is it?
I don't know for sure. I didn't look much into the differences between gzip and HPAC. Good question. A good follow-up. Server-side push promise. Bidirectional, like you suggested, Jeff, where the server can say, hey, you know what? I know you need file 1, 2, 3, and 4. Here you go, just have it. But in the same TCP connection, the browser can open up a new stream and make additional requests. Okay. Weights. You can also say, I feel jQuery has a higher weight value, a higher priority than this CSS file, or vice versa. So you can now add weight to your dependencies. So that's another addition that they've added.
So do you see that being used more for like giving the perception of performance as
Yes.
performance?
So what's the default?
I'm sorry.
What's the default?
Configuration?
Yeah.
So the weights. Like if you're to
I
out
think
of the box.
it's nothing. It doesn't add a weight.
So are these?
The browser might try to be a little smart about it, and you know what? Hey, you know what? I want to download CSS first. So I'm going to give that a higher weight. They already do that now.
The things that like block rendering, basically.
Yeah, they already do that now, but now they can utilize it a little bit better.
So you configure on the server the weight of a particular file.
Both.
Or you configure in the client?
Both. On both sides you can do it. And I'll get to that in a second on how you can do that. Dependency trees. You can also, it's smart enough to say, you know what, I know that jQuery is dependent on, or vice versa, that this JavaScript library that we wrote is dependent on jQuery, and it will create a dependency tree, kind of like the way that Webpacket does it for bundling. Okay, requirements. Browsers, they already support it. Let's,
Really? All the modern ones?
yep, let me show you.
Everyone think-
Let's go to here. Here we go. They all support it. I think IE might still be maybe partial, but the majority of them support it. Chrome does.
I was dead anyway.
Firefox, Edge does, yeah. So
I
yeah,
was actually curious about mobile support. Interesting.
they all support it. Pretty much mobile does as well. What color is that? Is that red?
Yeah, Opera Mini does
So Opera Mini, but whoever uses that,
Here's about all
right? Who cares about Opera Mini?
What are the asterisks
People
mean
look back
next to
on
the,
Where?
like iOS Safari? It's like, what does the asterisk?
mobile.
I don't know.
Well, because Edge is on there too.
It doesn't say.
Oh, can you hover over the star?
You try.
Where am I hovering?
The asterisk.
There should be a key at the bottom.
I know, there's not.
It didn't. I don't know. Okay.
Yeah, you'll see this a lot. The Speedy Protocol precursor. So Google had a lot of influence in this. Another thing I forgot to mention, there's a cool little Speedy guy that you can throw up something, a domain, it'll tell you if it supports HTTP2 or not, and what the protocols are using. If I throw one exchange in here, yeah, I don't get much.
Oh man, we have to even do it on the N5.
Yeah, the F5 would have to support it too, since we use it as the
There's some
yes, like front end.
there's some headers you have to add for it to say, yep, I support it. Node, there's some implementations for Node. You can get that spun up and play around with HTTP2.
Do you know? So IIS might not support Speedy, but what about like Kestrel or Kestrel? You know what
Mhm.
Kestrel does?
I don't.
Interesting.
I don't. There's also a little GitHub repo that they're using to communicate everything out to the world. So if you want more questions, it's a good place to go. All right, let's get back to this. Requirements. So the browsers already support it. Servers are getting up to speed. So if we want to use it here, we need to start using IIS 10. That's what supports it. And if we want to utilize the server push, and I might have this on another slide deck, we need to use ASP.core, ASP.NET 5. That's what supports it. We'd have to have that. HTTP semantics are the same. It's nice. Your get, all your verbs, everything's still supported. There hasn't been any changes in that, so it's backwards compatible. HTTPS is required.
Yes, that's awesome.
So
So you can't do HTTP2 unsecure.
nope, you cannot.
Nice.
Now, actually, the protocol, you can, but Firefox and Google require it. So I think pretty much everyone's good. And the reason is because when they were doing Speedy, they were coming into so many issues because the firewalls and the load balancers they weren't understanding what was coming over the pipe. Like there were stuff in the headers and everything, and they were trying to parse it, messing with it, and it was messing everything up. So they were like, you know what? Let's just make it secure so the firewalls don't screw everything up. The nodes.
The traffic.
Yep. Any questions so far? No? Okay, so what now? ASP.NET Core, that'll allow us to do push. There's a nice little framework around that. It lets you create dependency trees and all that fun stuff. We need to move to TLS, it's required. Now let's talk about what do we need to stop doing, start doing, and keep doing. I should have done keep doing first, but I think it's the last slide deck, so we're not way off. Okay. So stop inline assets. Shouldn't be doing that. And there's a reason. It's because we want to start utilizing again the caching abilities of the browser. If you do inline assets, well, for one, that just puts too much load on the initial initial page that goes out. There's no reason to do that anymore.
And browser can't cache it.
Mm-hmm.
I haven't seen too much of that.
We don't do it too much.
We don't do
That's
it,
why I was-
but like Google and others that are high traffic, they do. If you look at, maybe not now, but if you look at Google and other places, they inline the crap out of stuff just so that like render critical CSS is the first thing that's loaded.
A lot of times people put fonts in their CSS too, render fonts. Do we do that here? Our font list?
I don't think so.
Okay.
How would that compete with the movement, particularly around React, to move away from style sheets and into inline styles?
I think
say regardless,
Well-
don't do that because that's awful.
there's there's pros and cons to it. And it depends on who you talk to on if the pros are bigger or the cons are bigger, right? And they talked about that in this .NET Rocks podcast, which I suggest everybody go and listen to. What was the point I was going to get at? It was a really good one about that. Well, anyway, moving on. Stop concatenating files. So we do this. We utilize Webpack to bundle up our files so that we limit the TCP connections that are brought up, right? So the biggest thing, really, if you really want to take the biggest thing out of this, is we need to stop doing this right here. It's okay to bundle them if you know that artifact is going to be used 100% on that page. But if not, if you're not using all the code on that page, you do not bundle.
Yeah, in one exchange we bundle everything.
Yeah.
So the first page you hit, you get here's everything.
Yep. So no more bundling. And one of the other pluses about this is if I make a quick change to my X React component JavaScript, I don't
Has to download the bundle.
exactly. I don't have to download the bundle. The browser has already cached everything else. It already has cached the other 100 components that we've written. It only has to download that one component. So we can start utilizing caching the way it was supposed to be utilized. Okay. Right now, I don't think we're even utilizing caching, are we? Maybe we are. I don't know.
We did actually finally turn that on. For a while we weren't setting caching headers.
Oh, you know what? One thing I forgot to mention, another feature that's been implemented is they're now, and I had a good graphic for it, but they're it's all binary now. Instead of text over the wire, it's being converted to binary. And there's a lot of
Your
great.
HTTP request is binary.
Yeah, it's binary. That is another plus that I forgot to add to this slide. So like your tools, like WebShark, Fiddler, they need to be able to decompose those, and they do. They do.
So just be it's binary inside the TCP packet.
Mhm. Instead of text.
Just the payload or the entire thing?
That's a good question. I'm not sure if the header is.
Because it still has to route it.
Yeah, I
So
don't.
that's why
I don't think the header is. I think the header is just compressed.
Still.
Oh, whoops. That's not what I do. I hit the arrow.
Technically, everything's binary.
Yes. That's why I specified inside the TCP packet.
They're doing some special algorithmic stuff on there to make it so it's more performant and less load bearing. Okay, stop sharding. We don't do this, but well, I don't think we do. We do sharding?
We have like carrier images don't want to change, documents don't want to change. We haven't really done it for like scripts stuff. Like
Yeah, we
that
haven't
kind
gone
of
so
stuff.
far as to say like these images are on a cookie list domain kind of a thing.
And they don't really go into why. I guess more this is just, it just adds complexity.
I would imagine that.
Yeah, I wonder if it's
In
saying
that
don't
case-
do this or you can stop doing this.
Well, I
Then
think-
you have to have more than one connection, and each one has to manage because it.
So it loads latency, right?
Yeah.
You have blocks. You could potential block by opening up too many TCP connections, and you don't get the dependency tree.
Yeah, I was gonna say the dependency tree. You couldn't get that either. Because HTTP2 connections are persistent, right? They don't actually. Because right now with HTTP1, you make a request and you close it. That's why the handshake problem.
Mm-hmm.
But 2,
It stays open.
Stays open the whole time.
Yep.
So
So you can do a push.
The
Yeah,
way
that's where the
we
push
do
comes from.
things now with like plugins you want to discuss on a forum webpage or even just Google Analytics. How's that going to be? Because now you got.
That'll open up its own TCP connection. So you want to limit that. It'd be better to not reference that as a shard domain. You would, as a separate host, right? You want to.
Because the whole problem with sharding, just too many TCP connections, because generally it's good because it allows multiple resources to live one web.
It's good with HTTP1, right? But no, it's
Because of the TCP connections.
yes. Split items up. Don't bundle. Ship small, granular resources. We're kind of getting back
So
to that.
this is basically just going more to a lazy loading of delivering the content as needed.
As needed. Sure.
Instead of
Yeah.
eagerly loading like we do.
I guess this also helps us because I mean, already our React stuff, those are all separate files. We just in our build scripts compile them all into one, but we could leave it like our regular tree.
So keep minimizing the size of HTTP requests. That's still to do. Minimize the size of HTTP responses. So we still want to minify. Right? We still want to minify. We still want to make our JPEGs compressed. We still want to do all that. Start reducing DNS lookups. What I mean by that, and I'm not going to go into detail on it, but you can do DNS prefetches in your links. If you look at the bottom right,
Interesting.
because looking up DNS entries is a cost, right?
And browsers try to do that for you too. Like some of them will try to preload. Like they're like, I'm pretty confident you're gonna hit this link, so I'm gonna start preloading it for you. So I guess you can
Just
tell
pretty
it.
much says it. Look, you don't even need to worry about it. Just just do it. Start.
I'm familiar with DNS prefetch. Is that
It pretty much says, okay, the first time I'm going to go find out what the IP address is for spreadfirefox.com, I'm not going to go and try to find it every time again.
oh okay, gotcha.
Quick question.
Okay,
CND.
that's a little different.
It's
Content delivery network.
No, CND.
content network delivery.
Oh, I see.
Typo.
Oh, what did I do?
CDN. That's not CDN.
Oh. Well, let's see. What could I come up with? CND.
Isn't that abbreviated?
Cable network. Content network.
Start using a CDN, not for sharding, right? But start using a CDN for content delivery. And even if you want to go more about that, it means that we do not host our static files in our data center. Our JavaScript, our CSS, our HTML, yes, but our JavaScript and CSS, that is not hosted on our domain servers. Our domain servers or our web servers are used only for REST API servers, whatever you want to categorize that at. But that's what it's used for. Everything else is static, goes on a CDN.
I thought the primary benefit of CDN was for stuff like jQuery and Bootstrap, where
Well,
they're
that
used across multiple
there's
sites.
also the geographical aspect of it.
Yeah.
Um,
So we have trouble right now delivering assets to people on the East Coast because our only network is here in
the latency.
Utah, and the latency is pretty bad
Latency.
between New York City and here. So that would be useful to have it physically closer to them.
And it reduces the load on your server side servers. The ones that are
For us
doing all the logging.
specifically, I've actually seen it takes a while for the DNS resolution. When you try to hit one exchange, it takes it a little bit before it resolves the DNS.
And then leveraging browser caching by not bundling, not concatenating everything. Okay, so now I have a few demos I want to show you. Unfortunately, I couldn't do it locally. I was going to get notes set up, but I didn't. I wanted to try it on a Windows 10 machine, and I have that at home, but I wasn't going to get it going. So what I did instead is let me take this out of full screen mode here. There's some sites that have some demos that I want to show you. So here's a good site. What I want you to see. So this is how an HTTP 1.1 site works. Here's the protocol. Watch the timeline and watch how items download. Now you'll see the browser's doing some trickery to expand that 6 concurrent TCP connection limit. See the timeline. Nothing's downloading really at once. If I scroll down, can I scroll down? Does it not let me scroll down? if I could scroll, oh, there we go. You can see that, oh, that's another page. You can see that the items here are being downloaded at different times. Okay. Now, if I run the HTTP2 test, let me clear this. It downloads everything at the same time because there is no limit. It's opening up a multiplex streams and everything's being downloaded at the same time.
Why does it still reference HTTP 1.1
Oh wait,
under the protocol?
it shouldn't. Maybe they're because they have it on the same page. They're doing something where it's not reporting it right. So here's a better example. This one's a lot better. Clear this guy. I'm throttling it.
Does everyone know what those are?
These?
Yeah.
That's the
Go
Golang guy.
Gophers,
Yeah. So here you can see, again, it's downloading them all at the same time.
Oh, that entire image is a
Oh.
selection of images.
Yes, it's a
Okay.
collection
Yeah, I
of
was
images.
like,
Yeah, like
It's titled.
I haven't seen
tiled
that
image.
since
Broke them
4
up.
days.
So as you can see, it's not, there's no blocking going on. Each block, I think, is a little bit larger, and they did that on purpose, I believe, to show you. But you can see that they all start at the same time. Multiple streams can be opened.
Oh, yeah, so you can see it build slowly, but still see them.
Yep.
I see.
And it's used, here's where it's saying the protocol correctly, H2. All right, that's what I got. Any questions?
I have some questions.
Yep.
Regarding security. So in HTTP 1, most of the security, like cross-site scripting, always requires the user to click on a link because everything has to be requested. With HTTP 2, if it's just going to be delivered to you,
That's a good
how do
question.
you
I don't know.
have you run across that? Because not only do we have our customers, right, but when we are ourselves customers of other sites that utilize HTTP 2, how would we protect ourselves from accidentally getting stuff? Because right now it's, I don't click on an unknown link from someone I don't know, chances are I'm safe.
I think you might still have the,
Or does that have to do with the encryption and all that? I don't know.
well, yeah, I think this was the one I read. I think really they're just falling back on TLS is required, but I think all the other issues that come with HTTP1, I think they're still there. I don't think.
Because like you said, it had to be HTTPS, but didn't, or something like that. I wasn't too sure.
Well, no, I said that the protocol, the agreed upon protocol by the, I don't recall what foundation decides on this, but that's not in the spec. It's not required in the spec. But Google and Firefox are requiring it in the
browsers
browser.
Require it, but the protocols.
Yeah.
make it that.
I don't know about Edge. Edge, I don't think does. Let me see if Edge does. Where'd my, let's see, only supports HTTP2 over TLS. Oh yeah, Edge does. Looks like they all do, except for
Edge, Firefox, Chrome, Safari.
yeah, it looks like they're
They all
saying
do.
You have to
Yeah.
have HTTP2 over TLS,
Yes.
which is good. That's the way it should be.
So from what it sounds like, if all you do is upgrade your server, you'll see according to the stats, where's my statistic report? A 10 to 25% increase in speed by doing nothing but upgrading the server. After that, you implement server push and some other things on the server side that will increase that.
What's the best resource that you found for converting your
I really liked, and I can send this out. I really liked this guy right here. This is a really good resource, the cloudflare.com. In here they talked about, I think it was here that they talked about the binary. No, it wasn't this one. They talked about the binary feature as well that came out of it. I can't remember where it was at though. But yeah, I can send out some links. Here it is.
Message framing is binary.
Yeah, I didn't like this article. This one wasn't as good.
And this one does it contain like best practices, like you had?
This one kind of talks about the best practices. So anyway, that's what I had, you guys. Hope you liked it.
Go one more question.
One thing that I didn't find so I want to know more about how do I tell the client what I want to download first? How do I tell the client what to add more weight to and how to build this dependency tree? And there's not much out there yet on that. I was actually unable to find anything. Maybe I just need to narrow down my search.
Yeah, I wonder if you could. Did Speedy have that stuff in it?
Speedy does, yeah.
So you might be able to sort of reverse engineer or
Well,
forward
yeah.
engineer, like
Mostly all the articles are about, here's what you should start doing, here's what you should stop doing. Just, don't concatenate, right?
Basically stop bundling.
But no one's really talked about, here's how I make my server push. Because it's so new that there's not many articles about it. And then how do I tell my client, or how does the client tell the server what to do? There's not much out there yet. But yeah, Speedy would be a good reference because that's kind of where it was birthed from.
I mean, if it has a persistent connection, I wonder what that means for something like WebSockets.
Yeah. So I was wondering about
Where